Welcome to the Crazy Hat Chemist. So another video here on electrochemistry. So let's get moving. Bam! Ooh, whoa, this one is balancing. I'm on balance. Let's get balanced here. At the end of this here, we should be balanced. So balancing electrochemical equations number 8. All right. So we're going to balance the redox equation below. Here it is. This is the PbOH4 with a 2-. This is called a complex ion. You are combining a cation and an anion, and yet it still has a charge. It doesn't have a net charge of 0 like most compounds do. So that's why this is called a complex ion. All right, so the first thing that we're going to do here is we're going to write out the oxidation numbers for every single element. And for example, with the PbOH4 2-, the complex ion, we need to have that the oxygens are -2s. The hydrogens are +1s. And then from that information and the -2 charge, we should get the charge on the lead. And the charge on that lead is going to be a 2+. That's the plumbus. Okay? The oxygen is a -2. The hydrogen is a +1 like I aforementioned. Now, the next one that is a little bit complicated here is the ClO-1. This is hypochlorite. That's the hypochlorite ion. Okay? Now, the oxygen has a -2 charge, and this has a -1 charge as the ion does. Okay, and therefore that chloride is going to be a positive charge, and so we need to solve for it. Solving for that chloride ion is going to be a +1. That oxygen is a -2. All right, those are the complicated ones on that reactant side. On the product side, they're pretty simple here. So you have a lead oxide. We got to figure out, is this lead 2 oxide or lead 4 oxide, because there's a lead 2+ and a lead 4+. That's plumbus and plumbic respectively. So this has a net charge of a 0, and the oxygen has a -2 charge. Since the oxygen has a -2 charge and there are 2 of them, then the lead therefore is a 4+. Of course, the oxygen is a -2. That chloride is super simple because it has the charge of which it is, of which you would predict on the periodic table, and that's a -1. Now what we can do is we can define which 2 elements are undergoing a change in oxidation number from the reactant side to the product side. And that would be, first of all, the lead. That's going from a 2+ to a 4+. That's an increase in oxidation number. That's why that's oxidation. And then the chloride is the second one, and that's going from a 1+ to a 1-. That's a reduction in oxidation number. That's reduction, of course. So now what we're going to do is we're going to write our 2 half reactions. This is our first half reaction of the elements that are changing in oxidation number, and this is our second half reaction. So looking at that top half reaction, the oxidation half reaction, remember you're balancing the non-oxygens, non-hydrogens first. I have 1 lead on the reactant side, 1 lead on the product side. The leads are balanced. Now I need to deal with the oxygens and the hydrogens, the oxygens first. How many oxygens are on the reactant side? That would be 4. How many oxygens are on the product side? That would be a 2. So I'm going to have to add the number of oxygens that are unbalanced, which is 2, an equivalent number of waters, and therefore there are 2 waters. Now, I'm going to balance the hydrogens. How many hydrogens on the reactant side? There are 4 hydrogens on the reactant side. How many hydrogens on the product side? 2 times 2, that's 4 hydrogens on the product side. So the hydrogens are actually balanced. Now I need to balance this for charge. Okay, on the reactant side, again, that complex ion has a net charge of a -2. On the product side, the net charge is a 0. So on the reactant side, you have a net charge of a -2. On the product side, a net charge of 0. Remember, you always go towards the lower of the 2 charges, which is a -2 on the reactant side. So you're going to have to add 2 electrons to the product side. Fantastic. That half reaction is done. Now I need to worry about the second half reaction. So you're going to deal with the non-oxygens, non-hydrogens first. So the chlorines. So there's 1 chlorine on the reactant side, 1 chlorine on the product side. The chlorines are balanced in this case. Now I need to deal with the oxygens. There's 1 oxygen on the reactant side, no oxygens on the product side. And again, Balancing oxygens, you add an equivalent number of water molecules, so that's why we are adding one water molecule to the product side to balance up the oxygens. Now we're going to balance with the hydrogens. So there are no hydrogens on the reactant side, there are 2 hydrogens on the product side. So I'm going to have to add 2 hydrogen ions onto that reactant side. Okay, now this is where I'm just going to give a short little pause here. And I didn't specify on this problem what type of problem this is. But another hint on this problem is that this problem is in a basic solution. So this follows a different methodology than the previous problems. So in a basic solution, you balance it like it's in acid, like what I've done right now, and then you do that one additional step. That one additional step is by adding hydroxides that are equivalent to the hydrogens, but on both sides. That's that additional step that we're going to do right here in just a moment. Okay? And I do know that this is in a basic solution because either 1, it was stated, or 2, if you look at that complex ion, those are those hydroxides there. And when you have transition metal cations like that lead, that plumbus, with the hydroxide as that complex ion, more than likely it's going to be in a basic solution. So here's how we balance it in basic solution. First, you balance it like it's in an acid solution, like that's what I have done up to this point. Now what you're going to do is add an equivalent number of hydroxides as you have hydrogen ions. So on the reactant side, on the reduction half reaction, I have 2 hydrogen ions. So I'm going to add an equivalent number of hydroxides to that same side. 2. Now the rule is we're going to have an excess number of hydroxides eventually at some point in time. Okay, and in order to have that, I'm going to have to add hydroxides that are equivalent to the number of hydroxides that I added to one side. I'm going to add them to the other side. So I added 2 hydroxides to the reactant side. I'm going to add 2 hydroxides to the product side of that same half reaction, just like that. All right, now what we're going to do is we're going to take a look at that reactant side of this half reaction again. And there's something that's key here. You should see that there are 2 hydroxides and 2 hydrogen ions. The combination of a hydroxide and a hydrogen ion is a water. So if I have 2 hydroxides and 2 hydrogens, I get 2 waters. So I'm going to cancel out on the reactant side the hydroxides and the hydrogens, and I will have 2 water molecules. Fantastic. So now I have balanced this for mass. Now I need to balance it for charge. On the reactant side, I have a 1- charge. On the product side, I have a 1- with the chloride plus the 2- with the 2 hydroxides. That's a 3- charge on the product side. So I have a 3- charge on the product side, a 1- charge on the reactant side. So I'm going to add, you always go towards, again, the lower charge, which is a 3-. So I need the reactant side to have a 3- charge. It already has a 1- charge, so I'm going to add 2 electrons to that reactant side. Okay, now, again, the whole premise of this whole operation is so that the electrons cancel out. They must be on opposite sides. If they are on the same side, then you need to stop and restart. But they are on opposite sides here. So you should see that we will have this one in a basic solution, just like I aforementioned earlier. That means that there's an additional hydroxide ions. Okay, we're going to draw a line in the sand, and we're going to cancel out our electrons. Now, do we have any other things that we can simplify? You should see that on the reactant side, I'm going to have water molecules. On the product side, I'm going to have water molecules, and in both equations. So I've circled both of, or all of the water molecules in this case. So there are 2 water molecules on the reactant side and a total of 3 water molecules on the product side. I'm going to have the 2 water molecules are going to cancel out. I'm going to have only 1 on the product side. Is there anything else that is similar that I can combine or reduce? I don't think so. So I'm going to have to drop things down. Okay, and as I drop things down, I'm going to have that complex ion of that plumbus hydroxide with the 2- charge, that's PbOH4 2-, plus the ClO 1-, that's the hypochlorite ion, yields the plumbic oxide, that's the PbO2, plus the chloride ion, plus a water molecule and 2 hydroxides. Again, having those additional excess hydroxides either on the reactant or product side lets us know that this is certainly in a basic solution. So you should be able to verify that this is balanced. Of course, that is your last step every single time. I have 1 lead on the reactant side, 1 lead on the product side. I have 4 oxygens plus 1, that would be a total of 5. Okay, and then with the product side, I have 2 oxygens in the PbO2 plus 1 with the water, that's 3, plus 2 with the hydroxides, that's a total of 5 oxygens, so the oxygens are balanced. Okay, then the hydrogens, I have 4 hydrogens on the reactant side, and I have, with the water, I have 2 hydrogens, and the hydroxides, because there's 2, I have 2 hydrogens, that's a total of 4 hydrogens. There's 1 chlorine on the reactant side, 1 chlorine on the product side. It's balanced. Check. Awesome. Now I can label this. The PbOH42 minus there, that complex ion, is undergoing oxidation. It is the reducing agent. And the hypochlorite ion is undergoing reduction, and it is the oxidizing agent. That was a super cool problem. That was the first one of a few that we're going to do in a basic solution of balancing redox reactions. Okay, it's 1 step further than the acid balancing problems. So make sure you pay close attention to that. I am the Crazy Hat Chemist, and of course we can't end any video without a crazy hat. And this is a little bit of a hat for, hopefully you have something going on that you can celebrate. If you like that video, give me a thumbs up, and please pass my videos on to anybody that's in your chemistry class and let them know, hey, this is the best site that you can get video lectures and great problem solutions solved stepwise in a methodical method that's understandable. Okay? Subscribe to my YouTube channel, pass on my YouTube channel to all your friends in your chemistry class, that is. And you can find on my website and order yourself a sticker for your drinking flask and or a t-shirt if you want. So have a fantastic day. I'll see you next time. Bye for now.